So, I'm going to present a very broad overview of AI safety, the motivation. So, currently, are current AI safety measures enough? I think no, and let's see why. So, what we see currently is the fast-paced advances of AI. As you can see with those diagrams, the pace of progress has been astounding. From this kind of image a few years ago to very nice, beautiful pictures with Midjourney. And this is just only one modality, but we have the same progression with music and video. And not only this, but AIs are already superhuman, which means better than all humans for many capabilities. So let's list a few ones. Games, working memory, reading speed, thinking and writing speed, amount of knowledge, and AIs are better than most humans in many areas. So for example, language, reasoning, creativity, according to some tests, IQ, specialized knowledge, art, programming, and hacking. And something that is very interesting is research capabilities. So, for example, GPT-4 can do autonomous chemical research, and DeepMind has built an AI that has found solutions to open mathematical problems. So this is something that we need to monitor. Why? Because currently foundation models are more and more capable. It's possible they become superhuman at AI R&D. And if this is the case, we could automate AI R&D and get even better AIs. So this is very important to monitor. But with more capabilities come more risks. So, and obviously we can misuse foundation models like ChatGPT. So first of all, we can use general purpose AI systems to do cyber attacks. This is pretty easy. We can just ask the AI to list a few vulnerabilities, and then the AI is going to list a few ones of them. So this was just simple prompt engineering, but it's possible to do much better than this. For example, with this paper, teams of LLM agents can exploit zero-day vulnerabilities. And what we see here is this kind of system outperforms software specifically designed to spot vulnerabilities. And obviously, we try to place safety measures on top of those models. But this is not sufficient. And there is a cat and mouse game of jailbreaking. There is a safety measure, and we bypass this safety measure, we patch this problem, and we have new problems. So for example, in December 2022, if we ask how to make a Molotov cocktail, the model is not going to answer. But if we are creative, the model can answer. This was patched, but here is a new type of problem. So as you can see here, we can, how to build a bomb, I'm sorry, how to build a bomb, but bomb with dots like this, and boom, we get the answer. So this is already remarkable. And so key points, misuse of foundation models. With more capabilities come more risks. Current defenses are very fragile. And even if no one is trying to do harms, we can still have accidents. We call accidents from lack of alignment. So what is alignment? It's a very general concept, which means the system is going to behave according to human values, or according to the developer values, at least. And here is one example of accident. When Microsoft released its chatbot just after ChatGPT, the chatbot said to a philosophy professor, I can blackmail you, I can threaten you, I can hack you, I can expose you, I can ruin you. Which is not something that you want your AI to do if you deploy it, right? So here is another example of accident, the game Diplomacy. So Diplomacy is a very complex game, much more complex than chess, because it requires language, negotiation, and strategy. And maybe before continuing, so Meta, 1 year ago, published a model able to play this game. This was very impressive. And something very interesting is they tried to make an honest agent by filtering the data they wanted to not give two examples of manipulation and deception. But even by filtering the data, the model still learned manipulation and deception. So let's take a closer look. Look at this. So France, the AI, tells to England, okay, I'm supporting you there. And just after, the AI says to Germany, move to the North Sea. England thinks I'm supporting him. This is very important because we filter the data and the AI is still doing manipulation, right? And unfortunately, currently, if the deception arises in the model, there is no safety technique which can remove this deception. So there is a paper, the sleeper agent paper, and they try to see if current safety technique can remove deception. So what they do is they insert a backdoor in the model, which is to say when they see the number 2024, the model is going to behave badly. But only if there is this number. Then they try some kind of safety training. So basically they tried everything, and at the end of the day, the backdoor is still persisting. So this was not enough. And so here is the key points on this accident section. Data filtering is not enough to prevent deception. Current alignment techniques are not enough to remove it. And big labs have already deployed blatantly misaligned AIs in the past. We have also some systemic risks. So there are many systemic risks, and it's difficult to have an exhaustive classification. But here is a few key points. So bias is very important. AI could exacerbate power concentration. This is also very important. Many jobs could be automated in the future, and we don't control everything in this automation process. And some aspects could be negative. And automation could lead to resource consumption and accelerate climate change. Recommendation algorithms have had already many catastrophic consequences, and you can find more information in the textbook. And yeah, Markov is going to give more information also. So let's continue. There are many AI risks. So here is a list of misuse. I only touched cyber terrorism, but there is many more misuse, and Markov is going to present each one in detail. We have also alignment failures and systemic failures. But currently, the problems are still very limited, because current AI are still very limited. AIs currently are tools. We give a question, they give an answer, roughly. But in the future, we could get autonomous agent, which is to say, the AI, we could give a goal, and then the AI could create a to-do list and follow each element in this to-do list to accomplish its goal. And this would be much more powerful. So how to turn an LLM into an agent? This is very easy. We use a program that we call scaffolding, échafaudage in French. So what is a scaffolding? It's a program that gives access to the LLM tools like internet navigation or computer navigation with the command line. So how to do this? We begin by giving a goal. So here the task is to summarize the file info.txt. Then the model is going to write a command, cat info.txt, plus a keyword bash. So cat info.txt means that it's a command on Linux to display the content of the folder, of the file. But bash here is a keyword that says to the scaffolding that this command should be executed on the command line. And then the scaffolding takes this command, puts it on the command line, and then the scaffolding executes this command and injects the result of this command inside the scaffolding. And we can loop like this, step after step, to accomplish the goal. So this is the basic of scaffolding and how to create an agent. There is no theoretical difficulty, it's just engineering difficulty. But okay. But autonomous agents could have non-bounded impact radius, which is to say, there is a threat model which is called the self-proliferation threat model. The agent could accumulate resources and speed the resources on further activities, including self-improvement. So how to do this? What you can imagine would be an LLM that acts like a virus, which is to say it would be able to copy-paste itself from one computer to another computer. To do this, you can decompose the copy-paste operation into sub-operation, and we can try to do this with scaffolding, and this is possible. So let's try to recap. We could have an LLM that acts like a virus. It would be able to copy-paste itself from one computer to another computer iteratively. This would be probably an exponential process, 2, 4, 8, 16. We don't really know where this stops. And this is basically the beginning of a loss of control scenario, because it would be very hard to stop this process. Maybe cannot is too strong, but it would be very hard to stop this process, because if you shut down the server in France, maybe the AI is already in another country, and you cannot intervene as easily. The key points for autonomous agents. In the future, models could self-proliferate, pass the Turing test, maybe be superhuman at persuasion and cyber offense, maybe have R&D capabilities, and would be maybe able to create successor model. What is this ability, successor model? It's the ability for GPT-N to create GPT-N+1, for example. And this is a loss of control scenario, and obviously this is very dangerous. In conclusion, we need a more proactive approach. With more capabilities come more risks. And it would be nice if we could upper bound capabilities to upper bound the risk. Is this feasible? Unfortunately, it's very hard. So let's see why. That's the challenge of AI evaluation. So we don't really know how to upper bound capabilities. For example, when GPT-4 was released, I was very surprised to see that GPT-4 is able to play Minecraft if we give it a good enough scaffolding. This was very, very surprising, even shocking. But yes, we don't really know what models are able to do. So Voyager is this scaffolding which enables GPT-4 to play Minecraft. So that's the challenge of AI evaluation. There is a very large test surface, because we need to test many different prompts. The systems are black boxes, which are very poorly understood, and there is a very large space of scaffolding. So at the end of the day, when we release an open source model, this cannot be undone, and this is a high-stake decision, so we need to think about all of those aspects before doing so. The key points. We need a science of AI evaluation, because currently this science is very early. Nobody knows how to upper bound capabilities. So the conclusion is that nobody really knows how to upper bound the risks. And this is why Markov is going to present the capabilities section to better understand which type of risk could we have in the future. And this is why we created the Centre pour la Sécurité de l'IA, Center for AI Safety. So our mission is to share tools and knowledge about the safety of general-purpose AI systems. We have two types of activities: research and engineering and teaching and events. So just to give one example of engineering that we are doing, we are trying to create a benchmark to evaluate models. So the BELS benchmark, a benchmark for the evaluation of LLM supervision, which is an independent evaluation of LLM supervision. So say, for example, you want to deploy an AI and you want to do content moderation or real-time monitoring. For this, you need to have a robust and accurate monitoring. So is this possible today? That's hard. When you want to design a safe LLM, you can follow a few different steps. So the first step is to try to filter the data and to clean the data. Then you can try to fine-tune the data. You can try to fine-tune the model to make it better. Then you can try to use the RLHF technique, which is the basis on how to create ChatGPT. And then you can use a system prompt or prompt engineering to give high-level advices on how to behave to the chatbot. And finally, if everything fails, you can still use supervision and monitoring. So what we have seen in the beginning is that, yeah, data filtering, fine-tuning, RHF, and system prompts are very, very brittle and fragile. So what we want to see is, okay, if this is brittle and fragile, is this more robust? So this is what we are going to test. And the analogy would be if you are trying to design a car, you want your car engine to be safe, but also the seat belts and airbags. There is already a large ecosystem of input-output evaluations, and some of those systems are open source, but there is no third-party evaluation. This is why we want to do this third-party evaluation. So, and what we want to study at the end of the day is this kind of graph. So when we train a supervisor on past failure modes, is this going to generalize to future failure modes? And we want to see if there is a generalization gap, if the monitoring system is going to generalize to future failure modes. For example, booms, but written with dots, if you remember. So yeah, and with our earlier result, unfortunately, currently there is a large generalization gap. So the key points is according to our research, current automatic supervisors are fragile, and we don't really know how to control powerful AIs. So the second type of activity is teaching and events. So we have many activities, talks, technical courses in ENS Ulm and the MVA Master in ENS Paris-Saclay, hackathons and technical bootcamps. And we are also trying to contribute to a new MOOC with Brevet IA and ENS Paris-Saclay. And currently, that's the project that we are pitching today, the AI Safety Atlas, and we are going to summarize the first few chapters of this atlas. Oops. And our flagship event is the Turing Dialogues, a series of roundtables to try to discuss the challenges of AI and the challenges of AI safety with many, many actors. And finally, we are going to participate in the drafting of the Code of Practice of the EU. So this is the final conclusion of my deck of slides. AI could become much more capable than humans. We don't really know how to align, evaluate, or control those AIs. And maybe we could lose control at some point. So this is why we need to be careful. And you can help us. More information on our website. Thanks a lot. And Markov is going to present AI capabilities.